All right, so let's determine which pattern is different from the others. For A, we have an equation. B, we have a table. Um, Same thing with C. And then D, we have a graph. So let's compare everything with the equation. Let's try to take -5 and plug it in for x and see if we get out -14. So you take 3 times -5. That's -15 plus 1 is -14. We do the same thing with 412. Plug in 4 for x. If you plug that in up here, 4 for x, 3 times 4 is 12, and then 12 plus 1 is 13. So I'm questioning, there's some issue here. I don't believe, and if we actually want to try to find the rate of change, the slope, let's take -14 and -12 over -5 minus 4. We're subtracting the y coordinates over the x coordinates. That's going to give you -26 over -9, which is not +3. The negatives do cancel out. You get 26 over 9, but that doesn't reduce down to just 3. So A or B, one of those two, they're not going to work here. So let's check with C. Take -2 and plug it in for x up here. 3 times -2 is -6, and then plus 1 is -5. It does check out right here. Take 3, plug it in for x right here. 3 times 3 is 9, then plus 1, and that's 10. That checks out here. And then let's do 6. Plug in 6 up here. 3 times 6 is 18. 18 plus 1 is 19. That all checks out. So I'm thinking that B probably isn't going to be the answer. But let's go ahead and find the rate of change here. Let's do the rate of change with these 2 points right here. 19 minus 10, the y coordinates, over 6 minus 3. That's 9 over 3, and that's 3. So the slope here is 3. Again, the slope here is 3. And then let's go ahead and check D. 3x plus 1. We're going to see what that looks like on a graph. Is that what we graphed down here? 1 is the y-intercept. The slope, up 3 over 1, up 3 over 1. So this equation would be y equals 3x plus 1. All right, so you have the graph of 3x plus 1. You'd have the equation 3x plus 1. And then you have this right here, a set of ordered pairs that's going to be on that graph. So B is what's different than the others.